7,000 workers at a single factory in Filton, Bristol, built the only supersonic airliner ever to carry paying passengers across the Atlantic at twice the speed of sound. But Concorde was still earning British Airways up to £50 million a year in profit when Chief Executive Rod Eddington announced its retirement in April 2003. The aircraft had not failed. Airbus, the manufacturer that controlled its type certificate, simply refused to support 14 aging aircraft when its resources were needed elsewhere. This is the story of how corporate logic grounded the greatest plane ever built, and what Britain lost when it let that happen. Chapter 1. The Tramshed Gamble. A painter's son who left school at 15 built the company that would one day construct the fastest airliner in history. His name was George White, and in 1882, at the age of just 28, he was already making his mark as a solicitor's clerk in the offices of Bristol's legal firms. But White was not interested in the law as a calling. He was interested in the law as a mechanism for making money. He studied contracts, assessed risk, and developed an instinct for the commercial potential of new technologies that would define his entire career. By the time he turned 40, White had accumulated enough capital and influence to take control of the Bristol Tramways Company, running horse-drawn and later electric trams through the steep streets of a city that had grown rich on tobacco, shipping, and engineering. He understood public transport not as a civic obligation, but as a business. Collect pennies from enough passengers, maintain the rolling stock efficiently, keep the routes profitable, and reinvest the surplus into expansion. It was a philosophy of financial discipline applied to moving objects, and it would prove remarkably transferable to a technology that did not yet exist. In 1909, White traveled to France and watched Wilbur Wright demonstrate sustained powered flight at Le Mans. The American had been performing public demonstrations for nearly a year, drawing crowds of engineers, military officers, and curious spectators from across Europe. But what struck White was not the spectacle. It was the commercial implication. If a machine could carry a man through the air, it could eventually carry cargo. And if it could carry cargo, it was a transport business, no different in principle from a tramway. He recognized the opportunity with the same instinct that had drawn him to electric trams 3 decades earlier. What happened next would have been reckless from anyone without White's track record. He committed £25,000 of his own money to founding the British and Colonial Aeroplane Company, operating from 2 converted tram sheds on the outskirts of Filton, 3 miles north of Bristol city centre. £25,000 in 1910 was a formidable sum, roughly equivalent to £3 million today. White was not a dreamer. He was a businessman placing a calculated bet, and he wanted returns. The tram sheds were cramped, draughty, and ill-suited to aircraft construction, but they were cheap and available, and White understood that capital spent on facilities was capital not available for development. The early years tested that calculation severely. The company's first aircraft were crude machines of canvas, wire, and wood, designed by trial and error in an era when aerodynamics was more intuition than science. But White had identified the only customer with deep enough pockets and urgent enough need to buy flying machines in bulk, the British government. Military contracts arrived. Small orders at first, enough to keep the sheds busy and the payroll met. When the First World War erupted in 1914, the Filton factory transformed almost overnight from an experimental workshop into a mass production facility. The demand was insatiable. Every squadron on the Western Front needed replacement aircraft at a rate that peacetime production could never have anticipated. By the armistice in November 1918, Bristol had produced 5,300 F-2B fighters, the most effective 2-seat fighter aircraft of the war. The Bristol fighter, as it became known, earned a reputation among pilots for ruggedness and reliability that reflected the manufacturing standards White insisted upon. The workforce grew from dozens to thousands. The tram sheds expanded into hangars. then into a sprawling industrial complex stretching across acres of flat Gloucestershire farmland. Sir George White, knighted for his contribution to the war effort, did not live to see what his gamble would ultimately produce. He died in 1916, 2 years before the war ended, but his family continued to run the company, and the founding principle endured. Bristol was not an enthusiast's hobby. It was a commercial enterprise where financial discipline served technological ambition, where the balance sheet was studied as carefully as the blueprints. That DNA would prove essential 60 years later, when the company's successors attempted something no one had ever done: build an aircraft that could carry 100 passengers faster than a rifle bullet and do it every day, across the widest ocean on Earth. But before that aircraft could be built, someone had to solve a problem that the greatest minds in aerospace considered impossible. Chapter 2: The Aircraft That Broke the Rules. Archibald Russell, a bus mechanic's son from Gloucestershire, solved a problem that had defeated every aerospace engineer in the world. The problem was deceptively simple to state and ferociously difficult to answer. What shape should a wing be if it must fly efficiently at both 200 miles per hour and 1,350 miles per hour? Russell had joined Bristol Aeroplane Company in 1936, starting in the stress office where young engineers calculated the loads on airframe structures. It was unglamorous work, running numbers by hand and verifying that metal could withstand the forces that flight imposed. But it taught Russell something that more senior designers sometimes forgot. Aircraft are physical objects subject to physical laws, and every elegant drawing must survive the brutality of aerodynamic loading before it means anything at all. By the late 1950s, he had risen to the position of chief designer, and he was consumed by the question of supersonic transport. Every aircraft company in the Western world was asking the same question. The Americans had launched a federal program, the French had their own efforts at Sud Aviation in Toulouse, the Soviets were working in secrecy at Tupolev, but none had cracked the fundamental aerodynamic compromise. The difficulty was this: a conventional swept wing generates excellent lift at subsonic speeds, but creates unacceptable drag at Mach 2. A thin, straight wing performs well at supersonic speeds, but stalls dangerously at the low speeds required for takeoff and landing. Every designer who attacked the problem found themselves trapped between two contradictory sets of physics, and every compromise they proposed sacrificed too much performance at one end of the speed range or the other. Russell's breakthrough was the slender delta wing, a thin, elegantly curved triangular planform that could generate enough lift at low speed for safe takeoff and landing while maintaining efficiency at Mach 2. It was not a single flash of inspiration, but years of wind tunnel testing at the Royal Aircraft Establishment at Farnborough, mathematical refinement using techniques that pushed the limits of pre-computer analysis, and the accumulated experience of a man who had spent his entire career thinking about how air moves over metal. The slender delta was Russell's life's work distilled into a shape, and it was the shape that made Concorde possible. In November 1962, the governments of Britain and France signed a treaty that committed two nations to building what neither could build alone. The Anglo-French agreement was remarkable for two reasons. First, the complementarity was genuine. Britain had Rolls-Royce and Bristol Siddeley, world leaders in jet engine technology. France had Sud Aviation, with deep expertise in delta-wing airframes from its Mirage fighter program. The Olympus 593 engines would be developed on the British side. The airframe would be a joint effort, with final assembly lines in both Toulouse and Filton. Second, and fatally, the treaty contained no cancellation clause. This was deliberate. Both governments feared the other might withdraw when costs escalated, so they locked each other in with a legal commitment that made departure more expensive than continuation. The political logic was sound. The financial consequences would be staggering. The technical challenges dwarfed anything attempted in civil aviation. At Mach 2, Air friction heated the fuselage skin to temperatures exceeding 120 degrees Celsius. The airframe expanded by as much as 10 inches in flight, requiring every joint, seal, and structural connection to accommodate thermal movement without failure. Fuel was pumped between tanks to shift the aircraft's center of gravity as it accelerated through the sound barrier, a technique that turned the fuel system into both a power source and a flight control mechanism. The nose drooped hydraulically to give pilots visibility during the steep approach angle required by the delta wing. Every system interlocked with every other system in a web of complexity that demanded engineering of a precision the industry had never attempted. The original cost estimate was £70 million. That number, agreed in the treaty negotiations, was optimistic even by the standards of the day. But it was the figure that secured political approval, and by the time reality diverged from the estimate. The treaty's missing cancellation clause meant there was no exit. Russell would live to see the aircraft he conceived carry its first passengers, but he would also live long enough to understand that the treaty's structural weakness and the tiny fleet it produced had planted the seeds of destruction from the very beginning. Chapter 3: The Costs That Nobody Controlled. The program that was supposed to cost £70 million eventually consumed over $4 billion of public money. The escalation happened not in a single catastrophic miscalculation, but through a steady, remorseless accumulation of complexity, delay, and political stubbornness that stretched across 2 decades and outlasted multiple governments in both London and Paris. By 1966, 4 years into the program, the estimated cost had already trebled. By 1970, it had exceeded £1 billion. By the time the last production aircraft rolled out in 1979, the total expenditure had surpassed any comparable civil aviation program in history. The technical challenges were genuine. No one had ever built a commercial aircraft capable of sustained Mach 2 flight, and every solution generated new problems. The Olympus engines needed afterburners to push through the transonic drag rise, which consumed fuel at rates that terrified airline accountants. The fuel system, which doubled as a heat sink and a trim mechanism, required engineering tolerances that pushed the boundaries of metallurgy. The flight control system, which had to manage an aircraft transitioning from 200 knots to 1,300 knots and back again on every flight, demanded reliability standards beyond anything the industry had previously certified. None of this was waste. It was the honest cost of doing something unprecedented. But the political dynamics were equally responsible for the escalation. Anthony Wedgwood Benn, known universally as Tony Benn, served as Minister of Technology from 1966 to 1970 and became Concorde's most passionate political champion. Benn represented Bristol Southeast, a constituency whose economic life depended heavily on the aerospace industry. His advocacy was genuine and tireless. He believed in the program as an expression of British technological ambition, as proof that a medium-sized European nation could lead the world in the most demanding discipline of engineering. He argued forcefully in cabinet that 250,000 jobs across the country depended on its continuation. On the 5th of April 1969, Benn flew on a Concorde test flight, wearing a parachute strapped to his back and carrying a camera to record the experience. He described the flight as the most thrilling of his life. The image of a cabinet minister risking his neck in an experimental aircraft captured something real about the program's hold on the political imagination. This was not a procurement decision. It was a national project, invested with the emotional weight of the space race and the cultural significance of a cathedral. Benn's passion kept the program alive through at least 3 moments when cancellation was seriously considered. In 1964, the incoming Labour government of Harold Wilson examined the costs and recoiled, but the treaty had no cancellation clause. Walking away meant compensation to France so enormous that continuing was actually cheaper. The program survived not because ministers believed in it, but because they could not afford to kill it. a celebrated anecdote captures the strange mood of the era. A Scottish reader wrote to the Times to point out that the French spelling of the aircraft's name included a final E that had no place in the English version. Ben declared that the E stood for England, excellence, and entente cordiale, and the spelling stayed. Meanwhile, the airline orders that were supposed to justify the investment evaporated one by one. At the program's peak, 74 options had been placed by 16 airlines, including Pan Am, BOC, TUI, Qantas, and Japan Airlines. One by one, they canceled. The 1973 oil crisis made fuel costs prohibitive. Environmental concerns about sonic booms led the United States to ban supersonic flight over land, eliminating the most lucrative potential routes across the American continent. By the time Concorde entered commercial service in January 1976, only 2 airlines remained: British Airways and Air France. Both were state-owned carriers, and neither had chosen to buy the aircraft in any meaningful commercial sense. The British government effectively gave the aircraft to British Airways for £1 each, absorbing the development costs entirely. 14 aircraft entered service, 7 for British Airways, 7 for Air France. A fleet of 14 serving 2 airlines, flying a handful of overwater routes. Every vulnerability that would eventually destroy the program was embedded in those numbers. But those 14 aircraft would fly for 27 years, and they would earn hundreds of millions of pounds, and for the community at Filton, they would represent proof that the work had been worth doing. The question that nobody asked was what would happen when the companies that owned the aircraft's paperwork decided they had better things to do. Chapter 4: 7,000 Pairs of Hands. The Filton factory floor demanded skills that existed almost nowhere else on Earth. Building an aircraft capable of surviving sustained Mach 2 flight was not merely an engineering challenge solved on drawing boards and in wind tunnels. It was a craft challenge, requiring human hands to perform operations that no machine of the era could replicate, and requiring human judgment to make decisions that no specification could fully anticipate. The primary structural material was RR-58, a nickel alloy developed specifically for Concorde by the International Nickel Company. It could withstand the thermal cycling of repeated supersonic flight, expanding and contracting through temperature ranges that would fatigue conventional aluminum alloys within months. Machining RR-58 required cutting tools, feed rates, and coolant systems calibrated to tolerances measured in thousandths of an inch. The alloy was harder than anything the aerospace industry routinely worked with, and it punished imprecision ruthlessly. A single error in a fuselage panel could propagate into a stress concentration that would crack at altitude, where the consequences of structural failure were absolute. The margin for human mistake was essentially zero, and yet the work was done by hand, day after day, by workers who developed an intuitive understanding of the material that supplemented and sometimes exceeded the guidance in the engineering specifications. Filton did not build the entire aircraft. The program's Anglo-French structure divided the work with a precision that reflected the treaty's political balance. France manufactured the center and rear fuselage sections at Sud Aviation's Toulouse plant. These sections were transported to Filton inside the Super Guppy, a grotesquely swollen cargo aircraft derived from a Boeing Stratocruiser that remains one of the most visually absurd machines ever to fly. Watching a Super Guppy disgorge a Concorde fuselage section on the Filton apron was a sight that workers remembered for decades. The aircraft's bulging fuselage would split open like a clamshell, and the Concorde section would emerge on a wheeled cradle, gleaming in the West Country light. The enormity of the cargo emerging from the bulbous aircraft made the ordinary process of manufacturing feel like something from science fiction. At peak production in the early 1970s, 7,000 workers were employed directly at Filton on the Concorde program. Across the wider supply chain, the number reached 25,000. 700 supplier companies, scattered across Britain from the Scottish lowlands to the south coast, manufactured components ranging from hydraulic actuators to cabin fittings to the specialized sealants required for fuel tanks that operated under supersonic heating. The specialist trades represented on the Filton shop floor included airframe fitters, sheet metal workers, electrical installers, hydraulic systems technicians, engine installation specialists, and inspection staff whose training took years to complete. The operation represented what economists call a cluster, a geographic concentration of related skills, suppliers, and institutional knowledge that becomes greater than the sum of its parts. The community that grew around the Filton factory was not an accident. It was an ecosystem that had evolved over 6 decades. Streets of terraced and semi-detached houses spread outward from the factory gates in concentric rings. The local comprehensive schools produced a steady supply of apprentices who entered the factory at 16, learned their trade on the shop floor from men who had been doing the same work for 20 years, and expected to spend their entire working lives within walking distance of where they grew up. Fathers and sons worked side by side. In some families, 3 generations had clocked in at the same gates, starting in the First World War with George White's original workforce, and continuing through 2 world wars, the Jet Age, and into the supersonic era. The Concorde Sports and Social Club served as an unofficial community center, hosting darts leagues, football teams, family events, and Friday evening sessions where workers drank together and talked about the aircraft they were building with the casual expertise of people who understood every rivet in its structure. A BBC documentary filmed in the late 1970s captured something remarkable. Workers on the Concorde production line were asked whether they expected to fly on the aircraft they were building. Their answers revealed a poignant mixture of pride and awareness. They knew the ticket price, £8,000 and more for a return crossing, put the aircraft beyond their reach. They built the fastest airliner in history with their own hands and could not afford to sit in it. Yet they spoke without bitterness. The pride of craftsmanship was sufficient reward. They were doing something no other workforce on Earth could do, and they knew it. The documentary captured their faces as they spoke, weathered, practical, certain. These were not dreamers. They were tradesmen who happened to work in the most extraordinary trade available. At its height, the Filton operation consumed raw materials at industrial scale. Aluminium billets, titanium forgings, nickel alloy bar stock, and miles of electrical wiring entered the factory and emerged as an aircraft that could cross the Atlantic in 3 hours. The paint shop required specially formulated coatings capable of withstanding sustained skin temperatures above 100 degrees Celsius. The engine installation bay, where Olympus 593 power plants were mated to the airframe, demanded alignment procedures accurate to fractions of a millimeter across an interface that had to survive tens of thousands of thermal cycles over the aircraft's operational life. Each aircraft took roughly 18 months to build, and each one was slightly different from the last, incorporating modifications and improvements that reflected the engineering team's relentless pursuit of perfection. The testing regime was equally demanding. Every fuselage panel was X-rayed for internal flaws invisible to the naked eye. Every weld was inspected, documented, and signed off by name. The workers who signed those inspection sheets understood that their signature was a personal guarantee. If the panel failed at 60,000 feet, the signature traced the accountability back to an individual standing on the Filton factory floor. That weight of personal responsibility produced a culture of precision that visitors to the factory found remarkable and occasionally intimidating. But the production line was finite. Only 20 aircraft were built in total, including prototypes and pre-production models. When the last production Concorde rolled out in September 1979, the first great blow fell. The production workers were redeployed to other programs or made redundant. The skills they had developed over a decade of supersonic manufacturing began to scatter. Some moved to other aerospace companies. Some left the industry entirely. Some retired. And with each departure, institutional knowledge that existed in no manual, no drawing, and no computer system, walked out of the factory gates and was lost. The 14 aircraft in airline service still needed maintenance. But the critical mass was gone. The community of knowledge that had made supersonic manufacturing possible was dispersing, quietly and irreversibly, and no one was recording what was being lost. Chapter 5. The fastest thing in the sky. At 60,000 feet, passengers could see the curvature of the Earth through the cabin windows and the sky shading from blue into black. No commercial airline passenger before or since has experienced that view. Concorde did not merely fly faster than every other airliner. It flew in a different part of the sky, at an altitude where the atmosphere thinned toward the edge of space and the horizon curved visibly away from the aircraft's needle nose. Subsonic airliners cruised at 35,000 feet, packed into crowded air corridors and monitored by radar. Concorde operated alone at 60,000 feet, above the weather, above the traffic, above everything except the military interceptors that occasionally came up to have a look. The numbers defined a category of 1. Maximum speed, Mach 2.04, or 1,350 4 miles per hour. Cruising altitude, 60,000 feet, more than 11 miles above the Earth. London to New York, 3 hours and 20 minutes. The aircraft departed Heathrow at 11 in the morning, local time, and arrived at JFK at 8:30 in the morning, local time. Passengers arrived before they left. For the business travelers who constituted Concorde's core market, this was not a novelty. It was a competitive advantage worth the fare. A chief executive could leave London after breakfast, arrive in New York before the American business day began, conduct a full day of meetings, and return to London on the evening departure, arriving in time for a late supper. No other mode of transport offered that capability. Nothing else came close, and the fare was substantial. By the late 1990s, a return ticket on Concorde cost approximately £8,300. This was not first-class pricing on a subsonic aircraft. It was a category above, accessible only to corporate expense accounts, heads of state, film stars, and the genuinely wealthy. The passenger list on any given flight read like a guest list for a state dinner. Phil Collins was a regular. Mick Jagger flew Concorde so often that the cabin crew knew his preferences. Joan Collins, Henry Kissinger, and a rotating cast of Wall Street bankers, Hollywood producers, and Middle Eastern royalty filled the 100 seats on the daily departures. British Airways understood the asset it possessed. By the 1990s, the airline was extracting extraordinary financial performance from its 7 Concordes. Annual profits from the Concorde operation reached between £30 and £50 million. Over its commercial lifetime, the British Airways Concorde fleet generated estimated revenues of £1.75 billion. The aircraft had been given to the airline for £1 each by the British government. The development costs, the $4 billion of public money, had been absorbed entirely by the taxpayer. For British Airways, Concorde was pure margin, a machine that printed money on every crossing. But the aircraft's value extended beyond its balance sheet contribution. Concorde was a brand asset of incalculable worth. It appeared in British Airways advertising, on corporate literature, and in every press photograph of the airline's fleet. It told the world that British Airways was not merely an airline, but a flag carrier operating technology that no competitor could match. When Concorde appeared at air shows, it drew crowds that dwarfed the attendance for any other aircraft. Its distinctive silhouette, the drooped nose, the delta wing, the 4 engine pods, became the single most recognizable image in commercial aviation. The aircraft's cultural status, its presence in films, documentaries, and the public imagination reinforced the airline's premium positioning in ways that no marketing budget could replicate. The operational statistics told the story of a program that, for all its troubled birth, had matured into a remarkably effective commercial operation. By the year 2000, British Airways' 7 Concordes had collectively completed over 50,000 supersonic crossings. The fleet had carried more than 2.5 million passengers. Each aircraft flew approximately 1,000 hours per year, modest by subsonic standards, but extraordinary given the stresses of sustained Mach 2 flight and the intensive maintenance cycle that each sortie demanded. The turnaround at JFK required a crew of specialists who understood systems that existed on no other commercial aircraft in the world: the variable geometry engine intakes, the droop nose mechanism, the fuel transfer system that shifted tons of kerosene between tanks during every acceleration and deceleration cycle. British Airways invested heavily in its Concorde engineering staff, and the return justified the expenditure. Aircraft availability rates exceeded 90% in good years, a figure that would have been creditable for a subsonic fleet and was remarkable for supersonic. The loneliness of that supremacy deserves attention. The Soviet Union's Tu-144, Concorde's Cold War rival, had entered service with Aeroflot in 1970. It crashed at the Paris Air Show in 1973, killing all on board and 8 spectators on the ground. It suffered a second fatal crash in 1978 during a test flight. The entire fleet was withdrawn from passenger service after just 55 scheduled flights. The American Supersonic Transport Program, the Boeing 2707, had been canceled by Congress in 1971 before a single prototype was completed, killed by a combination of environmental opposition and fiscal caution. For 27 years, from the Tu-144's withdrawal to Concorde's own retirement, the Anglo-French aircraft was the only supersonic airliner in commercial service on the planet. Nothing challenged it. Nothing came close. It occupied a category that it had created and that no one else had the resources, the will, or the capability to enter. For the workers at Filton, this period represented a sustained source of pride that outlasted the production years. The aircraft they had built were still flying, still earning, still famous. Former production workers could point at the sky when the distinctive double-sonic boom rolled across the Bristol countryside and say, with complete accuracy, that they had built the aircraft that made that sound. Retirement parties, pub conversations, and family gatherings were shaped by the quiet certainty that they had done something extraordinary. When Concorde appeared on the television news, as it frequently did, former workers would watch with the proprietary attention of parents observing a child's achievements. They noticed things the public missed: the angle of the nose on approach, the condition of the paint, the quality of the landing. They knew the aircraft the way a cabinet maker knows a piece of furniture he built with his own hands. But beneath that pride, structural weaknesses were accumulating. The fleet was aging, parts were becoming harder to source, and the single document that determined whether Concorde could legally continue to fly was moving steadily further from the hands of anyone who cared about the aircraft's survival. Chapter 6: The 14 Aircraft Problem. Every weakness that would eventually destroy Concorde was built into its economics from the moment the last option was canceled. 14 aircraft was not a fleet. It was a rounding error in the global aviation industry. Boeing had built over 1,500 747s by the year 2000. Airbus had delivered more than 4,000 A320s. 14 Concordes, split between 2 airlines, operating on a handful of routes, represented a market segment so small that it barely registered on the industry's balance sheet. The consequences of that scale were relentless and compounding. Spare parts production for 14 aircraft was economically irrational. Every component unique to Concorde, and there were thousands of them, had to be manufactured in batches so small that the unit cost was astronomical. A hydraulic valve that might cost 500 pounds on a 747 could cost 5,000 pounds or more on Concorde because the production run was measured in dozens rather than thousands. A flight deck instrument panel component sourced from a supplier who made the same part for 10,000 subsonic aircraft could be produced economically. The same component for 14 Concordes required the supplier to set up a production run, calibrate equipment, qualify materials, and run inspection protocols for a handful of parts. Many suppliers simply declined the work. Others closed their doors entirely, victims of the same industrial consolidation that was reshaping the entire British manufacturing sector. As the fleet aged, the parts problem intensified. British Airways and Air France resorted to cannibalizing retired aircraft to keep the operational fleet flying, stripping components from withdrawn airframes like surgeons harvesting organs from patients who would never recover. The practice was legal, certified, and entirely standard in aviation maintenance. It was also a measure of desperation that would have been unthinkable for any fleet of normal size. The environmental restrictions that had confined Concorde to overwater routes from its first commercial flights never lifted. The sonic boom generated by an aircraft at Mach 2 was a pressure wave powerful enough to rattle windows, alarm livestock, and trigger complaints from communities hundreds of miles from the flight path. The United States banned supersonic flight over its territory in 1973, a decision driven by environmental lobbying and the lingering resentment of an American aerospace industry that had failed to build its own supersonic transport. Without transcontinental routes over the American landmass, Concorde was limited to the North Atlantic corridor, a single market that could support a handful of daily services but offered no room for growth. The aircraft that could fly at 1,300 miles per hour was confined to a single stretch of ocean. The closure of the production line in September 1979 was the first great structural blow. With no new aircraft to build, the production workforce was dispersed. The tooling, the jigs, the fixtures, and the specialized machinery that had been developed specifically for Concorde manufacture were mothballed, scrapped, or quietly disposed of when storage costs exceeded their assessed value. The institutional knowledge embedded in the production process began to decay immediately and irreversibly. Skills that had taken years to develop were carried in the heads and hands of individual workers, and when those workers retired or moved on, the knowledge went with them. No formal program existed to capture what they knew. No one commissioned a systematic recording of the tacit knowledge that distinguished a competent airframe fitter from a Concorde airframe fitter. But the most dangerous structural shift was corporate. The companies that had built Concorde were vanishing into one another through a process of merger and consolidation that had been accelerating since the 1960s. The British Aircraft Corporation, which had managed the British side of the Concorde program, was merged into British Aerospace in 1977 as part of the government's rationalization of the aerospace industry. In 1960, the government had forced 27 independent British aircraft companies into two groups, a brutal consolidation that destroyed corporate identities, displaced management teams, and subordinated factory-level decision-making to group-level strategy. That consolidation continued through the following decades, with each merger moving the center of gravity further from the shop floor and further from the people who understood what they were building. The critical transfer occurred when British Aerospace became BAE Systems in 1999, and BAE Systems subsequently transferred its stake in Airbus to the European consortium. Concorde's type certificate, the legal document without which no aircraft can fly commercially, passed through this chain of ownership like a deed passing through a succession of landlords who have never visited the property. It moved from the British Aircraft Corporation to British Aerospace to BAE Systems and finally to Airbus. A company headquartered in Toulouse with no emotional attachment to the aircraft, no institutional memory of its construction, and no strategic interest in its continuation. The company's focus was the A380, a double-decker subsonic super jumbo designed to carry over 500 passengers. Maintaining the type certificate for 14 aging supersonic aircraft was, in the boardrooms of Toulouse, a distraction from the program that would define Airbus's commercial future. The privatization of British Airways in 1987 had added another layer of vulnerability that few recognized at the time. As a state-owned carrier, British Airways had operated Concorde partly as a national obligation, a symbol of British engineering excellence that justified its costs through prestige as much as profit. As a privatized company answerable to shareholders, British Airways was required to justify every expenditure against commercial returns. For most of the 1990s, the returns were spectacular, and the justification was easy. But when circumstances changed, the privatized airline had neither the obligation nor the inclination to operate an aircraft for reasons of national pride. The safety net of state ownership, which might have sustained Concorde through a difficult period, had been removed 15 years earlier. Nobody noticed, because nobody imagined the difficult period would come. Lord Marshal of Knightsbridge, who served as chairman of British Airways through its most profitable Concorde years, would later say publicly that the airline had been forced into retirement by the French refusal to share maintenance costs. The truth was more structural than any single refusal. No single decision killed Concorde. The fleet's destruction was engineered over decades by the steady accumulation of small vulnerabilities. A fleet too small, routes too restricted, corporate ownership too distant, institutional knowledge too fragile. The question was not whether Concorde was vulnerable. The question was when, and from which direction the fatal blow would arrive. Chapter 7. The runway, the metal strip, and the hotel in Gonesse. A titanium strip 17 inches long, improperly fitted to a Continental Airlines DC-10 in Houston, Texas, killed 113 people and fatally wounded the Concorde program. The chain of causation was forensic in its cruelty, linking a single mechanic's error on one aircraft to the destruction of another aircraft, its passengers, and a hotel full of people who had no connection to aviation whatsoever. On the 25th of July 2000, Air France Flight 4590, a chartered Concorde service carrying mostly German tourists bound for a cruise ship in New York, began its takeoff roll on runway 26, right at Charles de Gaulle Airport. The aircraft was Air France's registration FBTS, one of the 7 French Concordes that had been operating transatlantic services for 24 years. The weather was fine. The aircraft was loaded within limits. The crew was experienced. There was no reason to expect anything other than a routine departure. During the takeoff run, at a speed of approximately 170 knots, the right main landing gear struck a thin strip of titanium alloy lying on the runway surface. The strip had fallen from the thrust reverser cowl of a Continental Airlines DC-10 that had departed the same runway approximately 4 minutes earlier. The strip had been fitted by Continental mechanic John Taylor at the airline's maintenance facility in Houston. The investigation would later determine that the installation was improper. The strip did not conform to the manufacturer's specifications. It should never have been on the aircraft, and it should never have been on the runway. The tire burst was catastrophic. A large fragment of rubber, weighing approximately 4.5 kilograms, struck the underside of the left wing at enormous velocity, creating a pressure wave inside the number 5 fuel tank that ruptured the tank structure from within. Fuel poured from the wing in a torrent, visible to observers on the ground. Somewhere in the cascade of events, measured in fractions of a second, the leaking fuel ignited. The aircraft was past the decision speed. The crew, led by Captain Christian Marty, had insufficient runway remaining to abort the takeoff. They rotated into the air, trailing a plume of fire that witnesses described as extending 30 meters behind the aircraft. A column of flames so intense that it was visible from motorways kilometers away. The aircraft remained airborne for approximately 90 seconds. Engine number 2 lost thrust. The aircraft could not accelerate. It could not climb. Captain Marty and First Officer Jean Marceau fought to maintain control of an aircraft that was burning, decelerating, and losing altitude simultaneously. At 14 hours 43 and 13 seconds, the aircraft struck the Hotel de Relais Bleu in the town of Gonesse, 4 kilometers from the runway threshold. The fireball consumed the aircraft and the hotel in seconds. 100 passengers died. 9 crew members died. 4 people on the ground, in and around the hotel died. The total was 113. Until that moment, Concorde had accumulated 27 years of commercial service without a single passenger fatality. The aircraft's safety record had been exemplary. The crash was not caused by any deficiency in Concorde's design, maintenance, or operation. It was caused by debris on a runway, dropped by a different airline's aircraft, installed by a mechanic who was later found to have used non-conforming parts. But the crash became Concorde's crash. The images of the aircraft trailing fire across the Paris sky, the wreckage of the hotel, the bodies recovered from the burning field, all attached themselves to the Concorde brand, with a permanence that no amount of technical exoneration could undo. The French Aviation Authority grounded the Air France Concorde fleet immediately. British Airways voluntarily grounded its fleet the following month. The grounding lasted 16 months. During that period, both airlines undertook extensive modifications to their aircraft. Kevlar linings were installed inside the fuel tanks to contain any future rupture. New tires, designed to be more resistant to debris impact, replaced the originals. Wiring in the landing gear bays was armored against debris strike. The total cost of the modification program ran into tens of millions of pounds per aircraft. The aircraft returned to service on the 7th of November 2001, with British Airways operating a special flight from Heathrow to New York, carrying invited guests and dignitaries. The date matters enormously. The 7th of November 2001 was less than 2 months after the September the 11th attacks that killed nearly 3,000 people in New York, Washington, and Pennsylvania. The premium transatlantic market that Concorde depended on had collapsed. The corporate travelers and wealthy individuals who had filled Concorde's 100 seats at £8,000 each were no longer flying. Some were afraid of terrorism. Others had been forced by their employers to reduce travel. Others had discovered that video conferencing could substitute for face-to-face meetings at a fraction of the cost. The business model that had sustained Concorde for a quarter of a century had been shattered by 2 unrelated catastrophes in the space of 14 months. In a French court in 2010, Continental Airlines and mechanic John Taylor were found guilty of involuntary manslaughter. Continental was fined €200,000 and ordered to pay over €1 million in damages. The conviction was later overturned on appeal in 2012, a reversal that satisfied legal scholars but brought no comfort to the families of the dead. For the Filton community, watching the crash coverage had been agonizing. The aircraft, whose reputation they had built with their own hands, was being destroyed on rolling news bulletins by another airline's negligence, and there was nothing they could do except watch and wait for the investigation to confirm what they already knew: the aircraft was not at fault. Former production workers, retired or redeployed, followed the investigation with an intensity born of personal investment. They understood the aircraft's structures, they knew where the fuel tanks sat relative to the landing gear, they knew that a foreign object strike of sufficient energy could breach the tank wall. And they knew, with the certainty of people who had built the thing, that this was not a design failure. It was a maintenance failure on someone else's aircraft. The distinction mattered enormously to them, and not at all to the traveling public. The 16-month grounding accomplished something that 27 years of safe operation could not undo. It placed doubt in the minds of passengers who had previously boarded without hesitation. Concorde had been invulnerable. Now it was merely safe, and merely safe was not enough to sustain a brand built on the absolute confidence that supersonic flight was routine. But the damage was done. The question was no longer whether Concorde could fly safely. It was whether the corporation that held the key to its future wanted it to. Chapter 8. The document that controlled everything. Noel Forgard's Airbus held a single piece of paper that determined whether Concorde would ever fly again, and Forgard decided the answer was no. The piece of paper was not a dramatic instrument. It was a bureaucratic one, the type certificate, the legal document issued by aviation authorities that certifies an aircraft type as airworthy and specifies the conditions under which it may operate. Without a valid type certificate, no airline can fly a commercial aircraft. Without a manufacturer willing to support the type certificate through ongoing airworthiness directives, inspections, and modification, the certificate becomes worthless. It is simultaneously the most mundane and the most powerful document in aviation. Airbus inherited Concorde's type certificate through the chain of corporate consolidation that had reshaped European aerospace over 4 decades. By 2001, when Airbus became a single integrated company under the umbrella of the European Aeronautic Defence and Space Company, the type certificate for Concorde sat alongside certificates for the A320, the A330, the A340, and the company's flagship development program, the A380. It was a legacy obligation inherited from predecessor companies, maintained by a small team of specialists, and regarded by Airbus management as an artifact of history, rather than a component of strategy. Noel Forjard, who became co-chief executive of EADS and head of the Airbus division, faced a resource allocation decision that was straightforward by corporate standards. The A380 program was consuming billions of euros in development costs. The double-decker Super Jumbo, designed to carry over 500 passengers on long-haul routes, represented Airbus's bet on the future of aviation. Every engineer, every certification specialist, every airworthiness expert assigned to maintaining Concorde's type certificate was an engineer, specialist, or expert not available for the A380. The arithmetic was simple, and from Forgaird's perspective, unanswerable. 14 aging supersonic aircraft, operated by 2 airlines, generated negligible revenue for Airbus itself. The A380 was expected to generate orders worth hundreds of billions of dollars over its production life. Supporting Concorde was not just uneconomical, it was, in Forjard's calculation, actively harmful to the program that would define Airbus's commercial future for the next 30 years. In early 2003, Airbus communicated its decision to British Airways and Air France. The company would withdraw technical support for the Concorde fleet. It would cease issuing airworthiness directives. It would not fund or certify further modifications. Without manufacturer support, the airlines could not legally continue operating the aircraft. The type certificate, the single document that kept Concorde alive, was effectively being revoked through administrative withdrawal rather than formal cancellation. The mechanism was quiet, procedural, and devastating. Lord Marshal of Knightsbridge, the former British Airways chairman who had championed Concorde throughout the 1990s and understood its brand value as intimately as any executive in the airline's history, was incandescent. He accused the French of forcing British Airways into retirement. His language in public was measured but unmistakable. British Airways had been given no choice. The airline wanted to keep flying Concorde. The manufacturer would not let it. Marshall understood what the balance sheet could not express, that Concorde's value to British Airways extended beyond its direct financial contribution into the realm of corporate identity, national prestige, and customer perception. Losing Concorde meant losing the single most powerful symbol of British aviation excellence. Rod Eddington, who had succeeded Marshall as chief executive of British Airways in 2000, was in a fundamentally different position. Eddington was an Australian with a background in cost management who had been brought in to restore profitability after a period of financial difficulty exacerbated by the September the 11th downturn. He was not sentimental about Concorde. He understood its brand value, but he also understood that British Airways was making staff redundant across the organization. Cabin crew, ground handlers, and maintenance staff were being let go by the thousand. Defending a supersonic prestige program while sacking the people who kept the airline running was, in Eddington's view, morally untenable and managerially indefensible. When Airbus withdrew support, Eddington did not fight. He accepted the decision and began planning the retirement with the efficiency of a man who had been waiting for the excuse to make a decision he could not justify initiating himself. Here is what made this situation particularly bitter for the Filton community and for everyone who believed the aircraft had a future. British Airways was still generating profit from the Concorde operation. The margins had narrowed after the crash in September the 11th, but the service was not losing money. Load factors had recovered to levels that most airlines would consider healthy. The aircraft was performing its role as a brand differentiator as effectively as ever. And yet the decision to retire was presented as inevitable, as a response to forces beyond anyone's control. In reality, it was a decision made by a small number of people in Toulouse and ratified by a small number of people in Waterside, the British Airways headquarters near Heathrow. The workforce at Filton, the passengers who valued the service, and the broader public who regarded Concorde as a national treasure were not consulted, because the corporate structure that governed the aircraft's fate contained no mechanism for their consultation. The strategic question that nobody in a position of authority was willing to address publicly was whether Airbus's decision was purely economic or partly strategic. Concorde represented a vision of aviation that Airbus was actively contradicting with every aircraft in its current product line. The A380 was a monument to subsonic efficiency, large, slow, fuel-efficient, and environmentally defensive. Concorde was its philosophical opposite. Keeping Concorde alive was not merely a cost to Airbus, it was a contradiction of the company's entire market narrative about the future of air travel. Whether Forgard and his board consciously calculated that Concorde embarrassed their product strategy is impossible to prove from publicly available evidence. What is provable is the outcome. Airbus withdrew support. British Airways and Air France had no legal mechanism to continue flying. The type certificate, the single most important document in commercial aviation, became the instrument of Concorde's destruction. Not a bomb, not a bullet, not a catastrophic structural failure. A piece of paper, withdrawn by a company that had inherited it through a chain of mergers it had played no part in creating and felt no obligation to honor. On the 10th of April 2003, British Airways and Air France jointly announced the retirement of the Concorde fleet. The announcement was coordinated, the language respectful, the substance absolute, but the announcement provoked a reaction that neither airline nor manufacturer had anticipated. Chapter 9. The offers they refused. Richard Branson offered £1, then £1 million, then £5 million per aircraft, and every time the answer was the same. The founder of Virgin Atlantic, Concorde's direct commercial rival on the North Atlantic route, launched a public campaign to acquire the British Airways Concorde fleet and continue operations under the Virgin brand. His initial offer of £1 per aircraft was a deliberate provocation, echoing the price at which the British government had originally given the fleet to British Airways in the 1980s. The message was pointed. If British Airways had received the aircraft for nothing, it had no right to complain about the price Branson was willing to pay. When £1 was rejected, Branson escalated. £1 million per aircraft, then $5 million. Each bid was accompanied by a media campaign that generated enormous public sympathy and considerable embarrassment for both British Airways and Airbus. Branson understood publicity the way Russell had understood aerodynamics, instinctively, comprehensive, and with a willingness to push boundaries that more cautious operators would have avoided. He gave interviews. He wrote open letters. He appeared on television with the easy confidence of a man who knew that public opinion was on his side and that the corporations opposing him would struggle to explain their refusal without sounding petty, obstructive, or both. Branson was not the only suitor. A heritage trust proposed acquiring one or more aircraft and operating them on a limited schedule of charter and special event flights, maintaining Concorde as a living exhibit rather than a static museum piece. The trust's business plan was detailed and, by the standards of heritage aviation, realistic. It proposed operating from Filton itself, using the runway where the aircraft had been built and tested. Private aviation enthusiasts with deep pockets explored the possibility of purchasing individual aircraft for personal use. Engineers who had worked on the program for decades offered their services, often at reduced rates, to any organization willing to keep the aircraft flying. They understood the aircraft's systems in a way that no newcomer could replicate, and they were offering that knowledge freely because they could not bear to watch it destroyed. The public response was overwhelming. Petitions gathered hundreds of thousands of signatures. Letters flooded newspapers. Members of Parliament raised the issue in the House of Commons, though none with the power or the political will to intervene. The emotional attachment to Concorde was genuine, widespread, and crossed every line of class, politics, and geography. It was one of the few things in early 21st century Britain that united people who agreed on almost nothing else. None of it mattered. Every proposal, regardless of the money offered, the operational plan presented, or the passion behind it, foundered on the same immovable obstacle: Airbus's refusal to release the type certificate. Without manufacturer support, no operator could legally fly Concorde. Airbus would not provide that support to a third-party operator, and it would not transfer the type certificate to any entity willing to provide it independently. The door was locked, and the key holder would not open it. No amount of public pressure, media coverage, or political intervention could change that fundamental reality. The type certificate was not a negotiable instrument. It was an absolute requirement, and its custodian had absolute discretion over whether to maintain it. This was the mechanism by which corporate power overrode democratic sentiment, not through conspiracy or corruption, but through the quiet exercise of a bureaucratic authority that the public did not understand and could not challenge. The asymmetry was stark. Branson had money, fame, and public support. He had operational expertise in transatlantic aviation and a genuine commercial plan. What he did not have, and what no amount of money or goodwill could purchase, was the consent of a foreign corporation to maintain a piece of paper. The entire future of supersonic aviation in Britain came down to a bureaucratic decision made in Toulouse by people who were answerable to their own shareholders and to no one else. Eddington, to his credit, briefly explored a charitable solution. British Airways considered establishing a trust that would maintain one or more aircraft in flying condition, funded by charitable donations and corporate sponsorship. The idea had a certain elegance that appealed to the airline's public relations team. It would have preserved the aircraft in operational form while removing the financial burden from the airline's balance sheet. It would have generated goodwill and demonstrated that British Airways valued the aircraft even if it could no longer justify operating it commercially. But the proposal required Airbus to cooperate on the type certificate, and Airbus was not interested in cooperation. The idea died in the same corporate corridor where every other alternative had been quietly suffocated by the simple refusal of a manufacturer to maintain a document. British Airways took a $130 million write-off on the Concorde fleet. The accounting treatment was clinical, an asset reduced to zero, a line item adjusted, a financial obligation discharged. In the annual report, the write-off occupied a few lines of text and a single adjustment in the balance sheet. What the write-off could not capture was the value of what was being destroyed, the engineering knowledge embedded in the maintenance workforce, the institutional capability accumulated over 27 years of supersonic operations, the cultural asset that no marketing campaign could replicate. The community of workers, passengers, and supporters whose lives had been shaped by the aircraft's existence. The competitive advantage of being the only airline on Earth operating supersonic passenger services. None of that appeared on the balance sheet, and none of it was considered in the retirement decision, because corporate accounting has no column for things that are priceless, and no formula for calculating the cost of destroying what cannot be rebuilt. The retirement proceeded on schedule. The final flights were planned with military precision and choreographed for maximum public spectacle. The aircraft that had not been defeated by a competitor, that had not been rendered obsolete by any superior technology, that had not crashed one time too many, was being killed not by failure, but by the withdrawal of administrative support, the most mundane and the most devastating form of institutional violence. What no one at British Airways or Airbus had calculated was the depth of grief that those final flights would provoke, or the lasting bitterness they would leave in the community that had built the aircraft with its own hands. Chapter 10. 25,000 people watched AN, it changed nothing. On the 26th of November 2003, Concorde 216 touched down at Filton and the engines were shut down for the last time. The aircraft, registration G BOF, had departed Heathrow that morning on a special positioning flight to return it to the factory where it had been built 30 years earlier. The flight was not a commercial service. It carried no fare paying passengers. It was a funeral procession, and everyone involved understood it as such. The final sequence had begun a month earlier. On the 24th of October 2003, 3 Concordes converged on Heathrow in a carefully orchestrated display that brought London's airspace to a standstill. One arrived from New York on the last scheduled transatlantic crossing. One arrived from a Bay of Biscay circuit. One arrived from Edinburgh. The 3 aircraft landed in succession, emerging from the overcast in a formation that had never been seen before and would never be seen again. Thousands of spectators lined the perimeter roads, climbed onto car roofs, and stood on the flat roofs of airport hotels. Office workers in the surrounding business parks came outside to watch. The BBC broadcast the arrivals live, and the coverage had the quality of a state funeral for a machine that had become, for many people, a symbol of what Britain was capable of at its best. But it was the Filton landing on the 26th of November that carried the deepest emotional charge. 25,000 people gathered along the approach path and around the airfield boundary. They stood in muddy fields, on motorway bridges, in pub car parks, and along the residential streets that bordered the factory complex. Many of them were former workers. Some had machined the fuselage panels of the aircraft they were watching descend. Others had fitted the hydraulic systems, installed the wiring looms, or painted the livery that caught the November light as the aircraft turned onto final approach. Some were the children and grandchildren of workers who had spent their careers at Filton. The crowd was not organized. There were no tickets, no barricades, no official program. People simply came because they understood, with an instinct that required no explanation, that they were witnessing the end of something that could not be replaced. Concorde 216 touched down on Filton's runway at 12:52 in the afternoon. The landing was smooth and precise. The aircraft rolled to a stop, and the 4 Olympus engines spooled down for the last time, their distinctive howl fading to a whisper and then to silence. Inside the cockpit, the crew completed the shutdown checklist, and the flight data recorder captured the final entry in an operational history that had begun 27 years earlier. Outside, 25,000 people stood in a silence that lasted several seconds. Then, they applauded. Then, many of them wept. Within weeks, the reality of what the retirement meant for the remaining Filton workforce became apparent. 100 maintenance workers at the Airbus facility faced redundancy. The specialist skills they possessed, the ability to inspect, repair, and certify a supersonic airframe, were not transferable to any other program in the world because no other supersonic program existed. These workers did not merely lose their jobs. They lost the context in which their expertise had meaning. A Concorde airframe technician in 2004 was a professional without a profession, a craftsman whose craft had been abolished by administrative decree. The knowledge dispersal was silent and total. No systematic effort was made to record what the workers knew. The skills required to build and maintain a supersonic commercial aircraft had been accumulated over decades of daily practice, and they existed not in manuals or computer systems, but in the muscle memory of technicians who knew how RR-58 alloy behaved under thermal stress, how the fuel system's trim transfer functioned under supersonic heating, how the Olympus engine's intake ramps responded to variations in atmospheric pressure at altitude. That knowledge walked out of the factory gates and was never recovered. The crowd of 25,000 represented the collective will of a community, a city, and arguably a nation, and it counted for absolutely nothing. No petition, no public demonstration, no act of popular sentiment could override the decision of a corporation that held a piece of paper. Chapter 11. The Nation That Stopped Building. After Concorde, Britain no longer built complete civil aircraft. It built components. The shift was not dramatic. There was no announcement, no ceremony, no moment when the nation's aerospace industry formally surrendered its ambition to design, build, and certify finished aircraft. The capability simply eroded, contract by contract, merger by merger, board meeting by board meeting, until what remained was a world-class components industry that excelled at making parts of other people's aeroplanes. Filton itself was transformed. The site that had built Concordes became an Airbus component facility, specializing in wing design and manufacture for the A320 family and subsequent programs. The work was technically demanding and commercially important. British engineers at Filton designed wings that were fitted to aircraft assembled in Toulouse, Hamburg, and Tianjin. The engineering was excellent, but it was the engineering of a supplier, not a prime contractor. The strategic decisions about what to build, how many to build, when to introduce new programs, and when to retire old ones were made in Toulouse, not Bristol. Filton had become a branch office of a European corporation, highly valued for its technical skills, but excluded from the strategic decisions that determined the industry's direction. The broader pattern was visible across the Southwest aerospace cluster. 43,000 people worked in aerospace in the Bristol and Southwest region, spread across 700 companies. The industry was alive. But it was an industry of participation rather than leadership, of components rather than complete systems, of technical excellence deployed in service of someone else's strategic vision. The decision-making power had migrated, and with it, the ability to determine what Britain's aerospace industry would do next. The corporate consolidation that had transferred Concorde's type certificate to Airbus was part of a wider restructuring that removed final assembly capability from Britain entirely. BAE Systems, the successor to British Aerospace, withdrew from commercial aircraft manufacture to focus on defense contracts, a strategic pivot that was financially rational and industrially devastating. The last complete civil aircraft designed and built in Britain was the BAE 146, a regional jet that entered service in 1983 and was manufactured in modest numbers at Hatfield. After that, the capacity to conceive, design, certify, and manufacture a finished commercial aircraft ceased to exist on British soil. The knowledge had not been destroyed in a single act. It had been surrendered incrementally, through a series of individually defensible corporate decisions that collectively amounted to the abdication of a national capability. The bitter irony arrived decades later. In the 2020s, Boom Supersonic, an American startup based in Denver, Colorado, announced the development of Overture, a supersonic airliner designed to carry 65 to 80 passengers at Mach 1.7. The company secured orders and commitments from United Airlines, American Airlines, and Japan Airlines. The manufacturing facility was being constructed in Greensboro, North Carolina. The engineering talent was being recruited from across the American aerospace industry, from companies and universities that had never built a supersonic commercial aircraft and were learning from scratch what Filton's workers had known from experience. The capability that Filton had pioneered, the knowledge of supersonic airframe design and construction that 7,000 workers had developed over 2 decades of daily practice, was being rebuilt. But it was being rebuilt in America, not Britain. The skills, the institutional knowledge, the craft traditions, the intuitions about material behavior and structural integrity that had been allowed to disperse without record after Concorde's retirement were not available to be recovered. They had died with the workers who held them, or faded into the uncertain territory of elderly memory. In June 2025, the United States lifted its long-standing ban on supersonic flight over land, removing the regulatory barrier that had confined Concorde to overwater routes and constrained its commercial viability for 3 decades. The restriction was lifted just in time for the Americans to build the next supersonic airliner. For the Filton community, the timing was not ironic. It was cruel. Former Concorde workers appeared in oral history projects organized by Aerospace Bristol. They spoke with a combination of pride that never diminished and grief that never quite resolved. They described the aircraft, the skills, the camaraderie, and the sense of purpose with the fluency of people for whom the experience had been the defining event of their working lives. They also described the ending, the abruptness, the powerlessness, the sense of something precious being discarded by people who had never touched it, never understood it, and never valued it beyond its line item on a corporate balance sheet. But if the workers' testimony was to survive, it would survive in a museum, and the museum stood where the factory had been. Chapter 12. The Museum Where the Factory Was. Aerospace Bristol opened in 2017 in the hangars where aircraft had been built since the First World War. The museum cost £16.5 million to construct, funded by Heritage Lottery money, corporate donations, and the stubborn, unfashionable fundraising of people who refused to let the story vanish. Lloyd Burnell, who led the project through years of planning and construction, described the museum's purpose in terms that were practical rather than sentimental. The aim was to preserve not just the aircraft, but the context, the skills, the community, the decisions, and the consequences. A museum without context is a warehouse. Burnell wanted something that made visitors understand not only what Concorde was, but what it meant to the people who built it and what was lost when it stopped flying. Concorde 216, the last Concorde to fly, sits in a purpose-built hall at the center of the museum. The aircraft is displayed with its nose drooped in the landing configuration, as though it has just touched down and might at any moment taxi back to the runway. Visitors can walk beneath the fuselage and look up at the underside of the delta wing. They can enter the cabin and sit in the seats where Mick Jagger and Henry Kissinger once crossed the Atlantic at twice the speed of sound. They can see the flight deck where the crew managed an aircraft that required more skill to operate than any other commercial airplane ever built. 16,000 engineering drawings have been archived. 8,000 artifacts, from tools to personal effects to fragments of the production process, have been cataloged and stored. The Concorde Memory Map, a digital archive of personal testimonies, collects the voices of workers, passengers, and community members before they are lost to time. The Filton runway, the strip of concrete where Concorde had taken off and landed for decades, where 25,000 people had watched the last landing, was closed in 2012. The site was acquired by developers and renamed Brabazon Bristol, after the Brabazon airliner that had been built at the same factory in the late 1940s. 2,600 homes are being built on land where aircraft once rolled to the threshold. The hangars that housed the production line are being converted or demolished. The physical infrastructure of a century of aviation manufacture is being replaced by the physical infrastructure of residential housing, because houses generate more revenue per acre than empty hangars. And the decisions about land use are made by people who calculate return on investment, not historical significance. The museum is excellent, the archive is valuable, the oral history project is essential. But none of it reconstitutes capability. Industrial knowledge is not information stored in drawings and databases. It is practice embedded in communities of skilled workers who learn from each other across years of shared effort, who correct each other's mistakes through daily observation, who develop intuitions that cannot be written down because they were never consciously formulated. 16,000 engineering drawings tell you what was built. They do not tell you how it felt to machine RR58 alloy at the tolerances required for sustained Mach 2 flight, or how an experienced fitter knew by touch whether a fuselage panel was seated correctly within the thermal expansion margins, or how the engine installation team coordinated a procedure that required 6 people working in concert in a space too confined for verbal communication. Those drawings are a recipe. The cooking was done by people who were no longer in the kitchen. That knowledge is gone. It did not have to go. It went because the institutions that held it did not value it, because the corporation that controlled the aircraft's legal existence had other priorities, and because the political and corporate structures of early 21st century Britain provided no mechanism for a community to protect its own industrial inheritance against the decisions of a foreign manufacturer acting from rational self-interest. Was it inevitable? The advocates of market logic would say yes. The fleet was too small, the routes too limited, the economics too fragile. Corporate consolidation was a global trend, not a British conspiracy. Airbus made a rational decision. Rod Eddington made a rational decision. Noel Forjard made a rational decision. Every individual choice in the chain was defensible in isolation. Each man acted within his authority and according to the metrics by which his performance would be judged. No one broke any law. No one violated any contract. No one was ever held accountable, because the system that empowered them did not require accountability for the destruction of industrial capability, only for the management of quarterly returns. But the cumulative outcome was the destruction of a capability that took 4 generations and $4 billion to build, a capability that existed nowhere else on Earth, and that cannot be rebuilt from archives, drawings, or museum exhibits. Every worker who clocked in at those gates for 30 years and believed the skills they carried would matter as long as the aircraft flew. Every family that bought a house 3 streets from the factory because the work was steady and the future was certain. Every young person who left school and walked through those gates because their father had done it, and their grandfather before them, and because building the fastest aircraft in history was a purpose worth giving a life to. They were not consulted. They were not compensated. They were not even, in any meaningful sense, informed. They were simply told that the aircraft they had built with their own hands would never fly again, because a company in Toulouse had decided that 14 supersonic airliners were not worth the paperwork. The question is not whether the decision was rational. The question is whether rationality applied without conscience, without accountability, and without regard for the human beings whose lives it dismantles, is a sufficient basis for governing the fate of industries, communities, and the knowledge they carry. Concorde 216 sits in a museum in Filton. The runway is gone. The factory is becoming houses. The workers are growing old. And nobody who made the decision to end all of this has ever been required to stand in front of the people it was done to and explain why.